It's basically you gotta find the derivative of this, and to do that, you gotta ignore this term because it's just like a constant. So I guess you could just take the derivative of of this with respect to t, which is just these two last parts of the first one. So take the derivative of e to the b minus c times t. This is just going to be a chain rule. So you just take the derivative of this term and hold it constant, and then add it to the derivative of this uh, this constant. So basically, first the derivative, this is b minus c times e to the minus t. Because there's a t there. This is just going to be a constant, even uh, constant. And then you multiply it by the first term, which is that, and and that one of your terms, and then to take the derivative of this, you got to take this as what it is, which is just e minus b to the c, and then you take the derivative of t. First, you have to bring the negative b over b minus to the c exponent, so you can have that, and then take that, and then you raise it to one less of a power, so you have whatever in the parentheses to one to the like one power. And now you can take the derivative of the t to b minus c times t, and to do that, you bring the b minus c down. So it's like the same thing as the first one. So now you have this whole thing written down, and then you can just that like combine both terms of b minus c times e to the b minus c together, so you can just like factor that out, and then once you factor everything out, you get this, right? And I'm not gonna cover that, uh, but and then like you see that like these two terms are the same, but they are like they're only different by one negative in the exponent. So what you can do is that you can factor out this to negative b over b minus e to a negative one, and then you get this form that you would have to just multiply um, this by 1 plus k e to the negative b minus e t. It should be in the parentheses here. But then once you get that, you can just factor. You can just do the factored version, and then which is plus k to the a minus b minus a b minus ct plus k to the b minus ct times b minus over b minus c is equal to 0. So by the zero product property, this it's equal to 0, and then so if you just set this one equal to 0, you have that, and then you want to multiply, simplify, and then you have to do the subtraction by this, but there's this coefficient in front, so basically 1 minus b over b minus c in terms of uh, b minus c over b minus c over b minus c, which is just negative c over b minus c. And then what you want to do is you want to plug that back in, and you just solve for this term, and then this is one of the ones that you want to isolate. And then you multiply this by b minus c over ck, and that's what you get on the left side. And then you isolate the two even more. You can just take the natural log of both sides, and when you do the natural log, you can just bring the exponent down, because uh, natural log of e is just 1. So after that, you just have natural log of b minus c over ck is just equal to b minus c times t, and this is in like the parentheses. So since everything's connected by multiplication, you have to multiply 1 or the system, and yeah, and then Emily will take it over.
Okay, now for the second problem, we're working with the numbers of 100 populations, which is represented by 100,000. And D is 0.28 and C is 0.2. which are each the rates of infection and the rates of recovery. So basically, if you use the formula from the last equation, the B minus C is just point away. So the formula for time is just 1B minus C, ln A B minus C over K. Then you plug it in over 0.08 times ln over 0.08 over 0.02 times 0.001 and plug that into the calculator, and you get approximately 74.89, which we round up to 75 days. And then the last part of the question is asking by evaluating this through the regular formula. So given the amount of people is 75, we plug everything in. And to simplify, you can just multiply the 0.28 and the 3.5 and the 0.08 times 75 is 6. So then you get 1 at 75 is 100 times 1.001 to the 3.5 times 1 plus 0.001 e to the 6, the negative 3.5 times e to the 6. And then we plug that all in, and we finally get the answer of 112,363 people.